Caleb, I don't know what Caleb did. Caleb took kind of a unique trail through that.
He's in my mythology class. Caleb's in my mythology class.
He did not take AP Lit or AP Lang. Okay, I'm just going to take questions. Reminder, you are not working on this with the person sitting next to you. This is your final, not their final. You are getting your answers. Reminder on the multiple choice, too. You must have a constructed response that matches the answer you got. In other words, you have to tell me why you got it. It does not have to necessarily be all the work, but I have to be able to determine, like, yes, that person actually got that answer from it, not Cam McCutcheon got C, therefore I got C.
Oh, that's hard.
Oh, hold on. Cam McCutcheon got C. Cam McCutcheon got it right, therefore I also got C. Yes, give me just a second. It's still firing up here.
I actually just have a general question.
Oh, yes, fire away.
My actual question. If we literally have a packet of them on multiple sheets of paper.
Yes,
you just
totally fine.
Okay. Would
Totally
that
fine.
need to write on separate sheet for every single problem?
No, let's not destroy the trees of the forest. You can use, you just, as long as there's a flow to it.
Yeah, they're all in order.
Okay.
Don't be a
Because I would be very, very annoyed if they were not.
Gotcha. And reminder, this
Do
is
you
out
have
of
a
your.
calculator I can use? Mine just died.
Yes, I just have this one though.
I have a charging cord.
Oh, can I use this?
Yeah, actually, I have it. There's a charger over there.
We can write, I guess, 40.
Yeah, anywhere. You can write anywhere in it, either on there or on the like a separate sheet of paper for your constructed responses on that. All right, let's go through. Let me make sure this is the BC one real quick. Yeah, it is. What would you like to work?
82.
82.
I will second that.
82. Now, real quick, as we're going through these, are there any problems that you don't know how to do?
Yeah.
Like after we go through it, isn't the math easy?
Oh,
Yeah,
yeah.
It's so weird how easy this test is, but how hard you make it when you take it the first time. If you don't know, LP, the first year they did a practice test, their average score went up by 1.3. 1.3. So where's everybody getting this fun cakes from?
That's because we did something at the district office yesterday, 2 years ago.
What?
Yeah.
I think I can
So Mr. Burke brought you cake?
It wasn't Burke, it was somebody else.
Okay.
District people?
Yeah.
Okay. 82. Can we talk about a problem?
Yeah, you've done so much and you haven't got your next one.
Well, like, because normally we end with our meeting at Mimi's, but instead of going to Mimi's, because
Yep.
the street says Mimi's,
Yep.
we went and looked at the construction site.
And then went to Mimi's?
No,
Oh, Dr.
they didn't feed us.
Dr. H.
So we all
Oh,
went
good
to
thing this is on the internet. All right, number 82. A problem that's so easy you make it hard. Question. Will somebody read the actual problem to me? Yes, Kiwi, fire away.
A particle moves along the x-axis so that at time t is greater than or equal to 0. The position of the particle is given by x of t equals 0.5 t to the fourth minus 1.5 t cubed minus 2t squared plus 6t minus 1.
Okay, how many of you are surprised you got this one wrong? Yeah, this one's so easy it's hard. So easy it's hard. Where's the origin at?
0.
What are those coordinates?
Oh my gosh.
X and Y coordinates, not what? They are not
T.
what coordinates? They are not t coordinates. And in fact, when t is equal to 0, where is this particle?
0.
No,
-1.
it's a -1. So here's what you got to do. What is the velocity of the first instance the particle's at the origin? So you've got to find out when this is equal to what? 0. And then you've got to plug it into its what? Derivative, right. That's what you got to do.
What?
So again,
You try
when t is equal to 0, where is the particle?
right there.
-1, which means it's 1 to the left, right. It is not, the origin is x equals 0, y equals 0, not t equals 0. That's the number one error in this problem that they're making sure your teacher's talking about. So x of t is equal to this. So when t is equal to 0, this is equal to -1. Now the good news is, what can you use to solve this? Yeah, you set this equal to 0 and solve for t. It's going to give you how many different answers for t? 4, right. It only wants which one? The first. So the first t value that makes x equal to 0. Then what are you going to plug that into? To find its velocity. Yeah, you're going to take the derivative of this and put that number in there. You're going to take that derivative and put that number into there. Now, you do not have to have the Inspire CXCAS to solve that. How do you solve it if you don't have one of those? You graph it and find the zeros, right. You graph it and find the zeros. Yes, the Inspire CXCAS is a nice, sleek package, but everything you have to do on this test, the 84 can do as well.
Can you give us like 3 minutes?
Yeah, go for it. Luke, at this point, it's your class. What you guys want to do? I've presented everything I need to do for you. So you tell me what you need, brother.
You put in the grades like the test grades.
Soon. Probably Saturday.
Saturday.
Brother, I am subbing every day this week. I only have one more planning period that I'm not subbing this week. Everybody's taking, there's so many teachers leaving. And then, of course, they all want to use their leave before they go because the days are useless. By the way, when you guys own your own business, just FYI, if you make days useless when people leave, they will use them all. So if you're a teacher, like we get 12 days off a year, but when you leave, they're worth nothing. My wife gets like 7 hours of PTO every pay period, but when she leaves, she just gets paid those out. If they're worth nothing, what are people going to do? They're going to use them. So like every day, there's like 18 teachers gone at the high school, and of course, every other school is experiencing that. So they didn't tell us we can sub anymore. They told us you have to sub. So yeah.
Is that why Ms. Watts subbed her release class?
Believe me, when those emails come out about PE classes, it's who's ever on their email the fastest. Like Breebach, yeah.
He subbed for Kobe's PE class.
Yeah, which apparently is just the boys in this class going to PE after this. Mr. Bailey apparently doesn't appreciate you as much as I do. Yeah, Breebach told me about that. Bailey's sub plan was, if you get sick of them, just have them sit on the bleachers and use their phones. I know, that's what I want to do sometimes. Like when I'm tired of teaching math, you all just take out your phones and we stop doing math. But
That's garbage.
according to Mr. Christofferson's senior picture up there, I have too much of a work ethic for that. Yes.
Wait, what's this thing? Just picture medication of it inside the interval? What?
Oh, I see it.
Did you?
Wait, Mr.
I
needed to solve for this.
Can I show that up there real quick? Can I show you Kamaketch's work on a problem real quick? Okay, this is just beautiful. Look at this work. Look at that answer. Why do you get 1 out of 2? Why do you get 1 out of 2? Beautiful work. Correct thing in the integral.
Is it not rounded right?
It's not rounded correct, right? So here's the bad news. If you don't round to 3 decimal places, you miss that entire right answer point. If you forget units, you forget that you miss that entire right answer point. Yep.
So first question, if it's like 10.50, do we have to do 10.500?
I would do it just to be sure.
Okay.
Leave
And
no
then-
doubt.
And then how do we get it to solve for?
Okay, well, you want to do what math class? Algebra, geometry, calc. So you go to menu, go to algebra,
Okay.
go to solve. Now here's the, now of course you're going to start over. So you plug in the equation, comma x. No, you want to solve for x. Or you can do t and plug it in for t.
Well, X was just like an easier letter to hit.
And Luke, by the way, I do appreciate you wanting to work that out too. So I'm more than welcome to give you guys time to work stuff out. Because I know you won't get that A in the class. Care about grades way more than I do.
We did 91.
Yep, give me just a sec.
I want to find on my exam.
That's what I want you to get, 5 on your AP exam. I expect every one of you in here to get 5 on your AP exam. I expect you to walk out of there and go, man, that was so much easier than I was thinking it was going to be at the start of the year. And then number 2, I want you to walk out and say, man, I freaking learned a lot in Calc BC. That is a great human accomplishment.
It really is. It's kind
I mean, question, have you learned more or less than you do in a normal class in this one?
Way more.
That's
I
one
mean,
answer.
more useful things like in mythology, we learn about like different creatures and like.
Well, brother, you would be shocked where mythology comes. Caleb, weren't you in the room the other day? I was talking about something I learned in my mythology class in college. First thing I learned was, thank God that class is multiple choice.
Ha! It's true.
Yeah.
The names.
And second off, I'm really glad that class was online because I didn't even start studying for it until the week before the final.
Well, that's what everybody's doing.
So I took all 4 tests of mythology in the finals week. All right, Ashton, which one did you want?
91.
91. Now, see how that's a must calculator problem too, by the way? You could do that by hand, but God help you. 91.
And 92.
91. Let's do 91 first, girl. 91 first.
87 to 92. I clutched out with 6.
87. Okay. Yeah, well, and be honest.
Actually, for real though.
I got 6 those
It's hard.
6 wrong.
Well, okay. A cup is a right circular cone. Okay, what's the trick of this
Wait,
problem?
it's 91.
What am I doing? 90? Sorry,
That's
91.
90. I mean, I'm okay with you doing 90.
Okay.
Yeah, I'm okay with you doing 92.
We'll do 90 later on. 91 is 91 is this weird equation that you have to memorize to get this one right. This one is about logistics growth, which is like a side note in chapter 5 in your notes, but this is one that you just have to remember. dP/dt is equal to K times, what is it? K times T. No, K times P times 1 minus. Okay, this is kind of a weird thing because this is called a logistics growth equation where there's three things in there. There's a constant of multiplication. There is P, which is the population, and M, that is the carrying capacity, which is the total possible population over a long amount of time. For like a half a second.
See, I remember this from
Wait, total possible
Yeah.
what?
This, in fact, this is a good example, but Ivy comes up with more of this because this is more of a relatable thing to calculate. Let me read. dP/dt is equal to K times P multiplied by the quantity 1 minus P over N. And is it to the T power?
Wait, what's C?
No.
There's no C. Where you say
What's C?
it's an M, duh.
Oh, M is the total possible of what?
Yes, and you may say, why is there an M in there? I don't know, because there's no M in the actual thing.
No, total possible what?
Total possible population. So let me explain what this is. So let's pretend that, oh yes, I have two buddies. I put them in this room. There's no disease, no predators, unlimited amount of foods, unlimited amount of water. And these two buddies really like each other a lot. A lot. And they are going to make bad life choices before they get married. Really bad life choices. Okay, you know already what's going to happen with these bunnies.
They're going to multiply.
They're going to multiply. That's what bunnies do. If you live right now, my God, the number of dead bunnies you see on the road. If you live right now, the number of dead bunnies. I should have said drive. If you drive right now, there are dead bunnies all over the place because the new ones are coming out.
Yo,
So, yes.
With the new
if you're walking up to the baseball field, there's a rabbit caught in the baseball cage net. I like suffocated itself.
Oh, that's a bad way to go. Bad way to go. But
Field trip, guys.
hey, that sounds like a physics field trip, not a math field trip. Okay, here's what you got to do. You got to solve for this K. The thing is, they want to make sure again that your teacher learned this. Now, I will be honest with you. If this is a question that this is just past your mental capacity to memorize, this is just one you guess on and move on to the next stage of life. You can, in some instances, tell which one the constant's going to be, but this is not one of them. They did a good job of hiding it. So here's what you got to do. There is a number of students who heard a rumor at time T. Guys, stop talking about that. It's modeled by a function T. The solutions to the logistics differential equation at noon, which is when we're starting, 50 of the students heard the rumor. The P is increasing. Okay, so let's put that in calc terms. P is increasing at a rate of 20 students per hour. So that is D, P, D. Right. Okay, so let's just fill in the blanks here. dP/dt is equal to?
20.
What's the population that knows this rumor right now? What's the total population that could hear this rumor? Yeah, because there's 500 students at the school. And this apparently is back in the day when they didn't have like Snapchat where you could just like text somebody from another school. But the people who write this test are way older than that. Okay, all you gotta do is solve for K now. That's it. Now, hold on. Notice, because on this is what? Identical, identical, identical. You just got to figure out what the constant is in front of it.
Okay.
Now, Willow, you are right. But this particular multiple choice only involves figuring out what that constant is. So again, the equation you have to have, dP/dt, you'll find it in your notes from one problem. We covered it one day at band camp. And what does this really mean? This is a growth rate where there is a total population that it can come close to. It can temporarily go over, but it's not going to for large parts of the time. Like there is a capacity, even if I give a limited amount of food and water in this room, because eventually there's just too many bunnies and they just start running over each other and they're having to eat poop and then bunnies die.
No more sad bed, just sad water.
Yeah, so there you go. You can figure that out. That's not the one problem after that. All right, next one. Volunteer, next one.
Oh, 88.
88. 88. So look at that. And if you love Haley and want her to be happy, the sooner you turn in that homework, the better for her. 88. 88. 88. Yeah, let's look at that one. Oh, this is Boy, this is one of those problems that's just absolutely wonderful. Absolutely wonderful. So I want you to finish this because this is a dirty Calc 1 trick. Dirty Calc 1 trick. Now let's go real quick as you're looking at this. This is a limit, derivative, integral, series, sequence, parametric, or Boolean question. Limit problems. So let's look at this. The graph of the function. I do want everybody on this one. This is a good problem. This is like a great approach. The graph of the function is shown in the figure above. The value of the limit as x goes to 0 of f of 1 minus x squared is. Now here's the dealio. The 0 is first going to go into what function? The 0.
1 minus x squared.
Right. So question. Are you plugging it into this graph first or 1 minus x squared? Okay, so what's 1 minus x squared look like, by the way?
It's upside down.
Right.
Negative x squared plus 1, so it's been.
Perfect.
Okay. Right? Okay, so first we gotta think of what's the limit as x approaches 0 of this. Okay, dirty dog trick though. It's not equal to 1.
What?
It's equal to 1, but only from what side?
Left.
Because the numbers are coming at 1 what? From beneath.
Oh.
So the limit of this is a dirty dog trick from Calc 1. Is equal to 1 minus, because they're only coming from the numbers beneath this. Because this problem should ring a bell to you real quick. It's way too freaking easy. Because it is. You're only coming at 1 from beneath it. So when you put that function in, you are going to be plugging in numbers that are going to 1, but only from which direction? From the left. So you're only going to come at 1 from which side? Which is why it is what it is. So you can determine what the limit is as x approaches 0 as you go to this from 1 from the left. I think I've made it pretty obvious what that answer is, but you have to actually select which one it is. Now, the dirty dog trick of that one is you're first only going to consider 1 minus x squared. It only goes to 1 from beneath it. So the numbers that are being put into f, are going to be less than 1. So you're only coming in at 1 from the left, which means you have to look at this graph at 1 from the left. And that's a dirty dog trick. But that's a dirty dog trick from Calc 1. Dirty dog trick from Calc 1. Now, let's take questions on that one before we go on to another one. And again, the theme of the AP test, they want you to what? Understand or memorize? They want you to understand, they don't want you to memorize. And this is their response to the Boba Betsy movement. Like, let's give you limits that, just Boba Betsy don't work for, because that's really honestly, Boba Betsy could have done in Calc 1, or you could have done that anyways, you did it now if you're in my class. This is their response to the memorization of calc. If they're going to put problems on there, you just cannot memorize your way out. You have to understand what it is. The numbers that are coming from 1 minus x squared into f are coming at 1 from the left-hand side. That's a great question. What's that? I don't know. It's not 7. I'll tell you, number 1, it does exist. Because first off, you look at that and you're like, well, the value is what? What do you think the number 1 answer is on that question? Yeah, E. Because the limit to the left isn't equal to the... And you're like, man, my calc teacher taught me that. I feel good about this. But then you feel like, that's
really easy.
Yeah, I know. And I will,
This is easy. And then it's like, oh.
so Willow and Sean, what I am trying to develop is that like range that these questions are in. They're not insanely hard, but they're also not insanely easy. So there's a range that if you go out of, like little bell should be going off in your head like that's a little bit too easy. So next one. Kiwi, you have your hand up. Next one.
I actually just wanted clarification on number 91.
Which is?
So the formula that you worked with us up there is different than like inside the parentheses.
Well, let's make a common denominator here. What's the common denominator?
500.
Okay, so what's 500 minus 50?
450.
So this is 450 over 500. Okay. Okay, so 550, goodbye, that leaves us with a 10. Copy dot reciprocal, so what do we get? 200 over 450? I feel like I'm working this one for you this way.
But that doesn't.
That's not any answers?
Hold
on.
Closest.
Hold on, Kiwi, hold on. Okay, what does this reduce to? Well, those go away. They're both divisible by 5, so that gives me 4 over 9. Is that not one of the answers?
That's the answer I got, but it's not one of the answers.
Yeah, let me look up my formula. What are you doing?
Looking for some paper that I left on your desk a while ago.
Why
If
would you
it's
be
a
gone
while ago,
forever?
it's
Black
probably not
hole.
there.
Probably on a Bestway truck. Let me look up the equation then, make sure I wrote it down correctly. Good thing about Google, the logistics equation is,
Yeah, I thought you missed something.
no, that is the correct. The PDT is equal to KP times the quantity 1 minus P over M. Let me make sure I did this correctly. At noon, 50 of the students. Oh, let me see if this works real quick. Hold on. Let me see if this works. Oh, differential logistics equation. What's up, brother?
We on the YouTube?
Yeah, we're on YouTube. Don't say anything that's going to get you fired.
Man.
So I got 4 over
Sometimes when I
9.
talk calculus, I get excited.
So it's going to be 1 minus P over M. P is 5, or M is 500. So they made a common denominator here. Oh, okay. This is a dirty dog algebra trick.
No such thing.
Okay, question. This looks like all the answers except there's not a what? Yep. This looks like all the answers except there's not a what? 500 in the denominator. So what do you think they did with that 500? Yeah, I carried it over to here. That's going to get you the right answer then. They just made a common denominator. So here has to be.
4 9s times 1 500.
Has to be the right answer.
4 over
Hold on.
500, what is that?
4,
That's good. That works out.
4 divided by 9.
Yes. It is it.
Let's convert that to a fraction real quick. Yeah, that's one of the answers. Better work out, or otherwise I don't know how to do this problem.
It works out.
Yes.
Mason Banks, you still got him in class?
No, I do not.
Kevin Carter, got him
Yes, I
in
got her
class? Christian Wacker, got him in class?
Yep.
These are the 2 students that you have that have checked out calculators.
Okay.
This is the only record I have of what calculator they have. So don't lose those. I'm gonna
Do they
leave
have
them with
calculator
you.
numbers on them?
Yep. And if they give back the calculator, you can just rip that up and throw it away.
Okay.
All right. But if they don't give back the calculator,
Okay. You didn't make an Excel form of that?
no.
Okay. All right, another one you want to work on. Willow,
90.
90.
Can you go to free response next?
Yeah. Brother, I'm just taking questions. That's all we're doing is taking questions.
Awesome.
All right. Number 90 is a great question. Soon as you see this question, you got to remember the trick to this puppy is what?
Don't be stupid.
Don't be stupid. No, this one's actually pretty hard. There's a specific thing you have to remember, and I'll give you a hint. It's from geometry class. Probably the last time you used it was on your ACT, SAT.
Oh, yeah.
Oh, we did the-
Yeah, ratio, because the triangles are what? Yeah, similar triangles. So let's set this one up. Set this one up. All right, so the first thing you do with these is draw what?
Picture.
Picture, right. So we got a cup. It's a cylindrical right cone. You guys probably don't even remember, but you used to go to the water fountain and get one of these cylindrical right cone cups. Why is it a right angle? Because the angle is straight up and down. It's not to the side. It's a straight up and down cup. So the right angle is actually right here. That's what makes your right triangle. It makes it with the height and the radius. The height and the radius. Let's see what we got on this one. We got a cup. It's 12 centimeters tall. And it has a radius of 3. Do note, they love to give you the diameter instead of the radius, which is just a dumb way to miss this question. But water is poured at a constant rate of 2 centimeters per centimeters cubed, hopefully, per second. Okay, question. That is what? Let's talk calculus with that number. 2 centimeters per second is D.
Rate.
D what? D what? dV/dt, right? That's dV/dt. Now, I've been kind of jokingly, but kind of serious, been running up to the IB kids and telling them, hey, don't forget this question, this test, write your answers in English, not calculus. On the calculus test, remember you have to talk calc on free response. So as soon as you get stuff, put it in calc terms, dV/dt, the integral, something that's calculus talk. It's poured into a cup 2 meters per second. The rate at which the water is rising is that when what is the rate the water is rising at? So they want d what, d what? The HDT is what they want at the end of the day when the depth is 5 centimeters. Okay, now let's go back to volume. Oh, look at that. They're nice to us. They gave us volume is equal to 1/3 pi r squared h. Problem, how many variables are in that?
2.
Are you in multivariable calculus yet? No, but some of you are going to be this summer. You are in single variable calculus still. So we need to get this down to a v and a something else. We'd really like to get rid of the what? R, because these are both in terms of h. So you somehow like to get rid of the r. Now, Sean gave away the secret. How do we do that? There is some abstract triangle in here that is h tall and r wide. This triangle is similar to this one. There's a proportional ratio between the side lengths. So the ratio of r over h is equal to 3/12. And we'd really like to get rid of the what again? R. So we're going to solve this for R, right? Because they're going to get it in terms of h. H will just get us, h is up here, and then I'll let you finish the problem. So cross multiply, so you get 3h is equal to 12r. Let's call somebody who looks chipper and excited. Ayana, what should we do to solve this puppy for R? No. No.
We're not solving
Yeah,
for R?
solve it for R. Solve for R.
Oh, divided by 12.
Yeah, divided by 12. So you get h over 4 is equal to r. Now we are going to take that and we are going to replace r with that. Now somebody said plug in 5. The problem with plugging in 5 is you are not going to get what you need from this yet. We're going to plug in 5 at some point, but the first thing we're looking to do is take this down to a v and another variable. So it's just 2 variables. I don't want the dt, the rdt, r's and h's, and a v. That's 5 variables. That's way too many for me to deal with. So volume is equal to 1/3 pi h over 4 squared multiplied by h. And I believe Luke or whoever back there said it. You don't actually have to find what r is equal to because now we just got what? H's. We're going to get a dv dt. We're going to have some h's. We're going to get a dh dt. We know what h is. We know what dv dt is. We can solve that for dh dt. And I'll let you finish the calc and the algebra.
Can we have a moment to look at
Of course. It's your class. Yep.
You see that video of the teacher appreciation week?
I did.
I appreciate you.
Thank you.
Yes.
You didn't make the cut, though. I didn't see you in it.
I was the first one.
Oh, sorry. I was walking in late. I had some kids
Did
that
you
showed
see
up
me?
at the time. I saw you, yeah. Saw you. I saw Cameron Todd.
JoJo.
Saw JoJo. Shalaka. Who else is in there? Brianna Hunt. She'll be in BC with me next year. Who else is going to be with me next year? Kaltoff will be in BC. Lorenz will be in BC.
Yeah.
Why is that funny?
No, I'm just thinking about the people who are going to be at BC next year.
I've had them I will have had most of them 4 out of 5 years. Kaltoff, 4 out of 5 years. Lorenz, 4 out of 5 years. So I had them in 8th grade, 9th grade, 10th, 8th grade, 9th grade. They took pre-calc, 10th grade to Swinghammer. Then I had them in 11th, 12th grade.
What if y'all 5s, you won't teach them?
Yep. I'm just letting you know. If y'all get 5s, I'm retiring. They can have whoever takes my job. I will go on the lecture circuit and tell everybody, how can you get your class to get a 5? Scare the pudding out of them on a practice test a month before the real test. What's that? DHDT. Yep, just a second. Let's give people a minute to finish this one. So remember, you're first going to want to simplify and then take the derivative. And that's just a power rule problem. But remember, we're taking it with respect to t. So everything that doesn't have a t in it, you want to have a d or a d something to t. Ashton, you said what? Actually, at the Camp McCutcheon, I think you were in first.
That's
I
okay.
said it
She
a
can
while
go.
ago.
I figured it out.
Okay.
Well,
This- Okay, this one I think I've already worked.
Oh, really?
So I'm gonna actually, just like I need to get a fresh copy of this.
That's probably not on it.
Oh, by the way, there was a partner pop quiz last time. If you were not here, don't forget, you need to take that to get all of the deals I've talked about in this class. You can do it right now, actually, if you want to. It's really fun.
Oh, what's my partner? It's easy for partners.
Caleb, Caleb, you need a partner? Caleb, I want to be your partner.
Caleb?
Dibs.
Caleb?
Caleb.
Yeah, a class test.
Yeah.
No.
Caleb,
All right, 92. 92 is a good example of understanding, not memorization. So 92, let f be a positive, continuous, decreasing function. Now, I've told you this a million times, and I know I'm getting old, but they never give you what? They never give you what?
Something you don't need to use.
Right, they never give you something you need to use. So I'm going to go back at some point and talk about why did we need all three of those? Because one of them seems like we don't need it. So f is a positive, continuous, decreasing function, and the integral from 1 to infinity of f of x dx is equal to 5. Okay, so we can use the integral test to definitely determine this one what?
Converges.
It converges. If the integral converges, the series must converge. It's harder for the integral to converge than it is the series to converge. Now, last thing. The integral test is the blank test we use. The very last test we use. We have no hope. We have decided to make our lives miserable, so we use the integral test as the very last test we go. Okay, so then it says, is the sum equal to 0? Is it converge and the sum's less than 5? Is it equal to 5? Is it converge and is greater than 5, or does it diverge? Now, which one do we know is wrong?
Diverge.
Yeah, we cannot diverge because the integral converges, therefore the corresponding series must converge. Okay, if this sum is equal to 5 and it is positive, can this be equal to 0?
No.
No. If this is equal to 5, it's positive, continuous. Could the sum be exactly 5? No, because the integral is summing up what?
More.
Every single point. The summation is just summing up the whole numbers. Now, the summation is like taking a Riemann sum that has a delta x equal to what?
1.
Well, let's talk to you guys. Who looks chipper? Before you look chipper. If I'm doing this series right here, what's the first n value I'm going to put in? No, 4. 1. And then the next one is? And then the next one is? So when I get that value from the first one, it's kind of like I did a Riemann sum that had a delta x equal to what? 1, right. So it's kind of like doing a Riemann sum with the delta x equal to 1. So let's draw out. We have a positive, continuous, decreasing function. Continuous because obviously the integral may not exist if it's not continuous. Okay, positive, decreasing. Okay, question to you. What's the first value you're going to plug in? 1. What's the next value you're going to plug in? What's the next value you're going to plug in?
Goes.
What's the next value you're going to plug in?
3.
What's the next value you're going to plug in?
4.
Okay, question. Is the integral less than or greater than your summation? Is the integral less than or greater than your summation? The integral is less. Why? Because every time you plug in a number, you're going to use that for the entire thing. On a decreasing, the sum is an overestimation. On an increasing, the sum is an underestimation. So is the sum of the series going to be bigger than 5 or less than 5? Look at my boxes. Are my boxes, if the integral is 5, are my boxes going to be bigger than 5 or less than 5? Okay, you got to figure that one out on your own. But I will tell you, the key to this one is drawing it out and realizing you must use the fact that it's decreasing. The fact that it's decreasing when you draw the boxes in, because you're going to plug in 1 and use that for the whole value. You're going to plug in 2 and use that for the whole value. 3 and use that for the whole value. 4 and use that for the whole value. Now, I do want to take questions on that one, because it doesn't really matter if I know how to do this if you don't know how to do this. Guarantee there'll be one of those on there because that's a dirty dog trick of understanding how the integral and the summation are different. We use the integral test to definitely tell it definitely converges. Definitely converges. the sum can't be equal to 1, or can't be equal to 0 because they're always positive. If you add up a whole bunch of positive things, what can the sum never be equal to?
0. Whole bunch of positive things?
If you add up a whole bunch of positive things, the sum certainly cannot be equal to what? Can't be equal to 0. So we know A and E are incorrect right off the bat. Now, they never give us more information than we need. So we use the fact it's positive to determine that. We use the fact it's continuous to use the integral test to be able to determine it does not diverge. We must also use the decreasing to draw a map or to draw a picture of what this looks like, and then draw in what our summation is going to find and relate that to the sum they gave us up here. So they never give you more information than you're going to use. You have to use everything they tell you. And that's how we use that decreasing one for that, is to draw that picture. We draw in our Riemann sums, which is what our series is going to approximate. That tells us if the sum is going to converge, diverge, and if it's going to be greater than or less than 5, given that the integral is equal to 5.
One more calculator paper for you.
Gotcha.
This girl started with me, and I felt like she was too
She's
smart.
nice. Yeah.
Was she too smart for me?
She should probably be in music.
Okay. Yeah, I remember teaching her for like a day and being like, "You're too smart."
Well, here's the good news on that
Well,
one.
hang on,
She
exactly.
definitely ruined the American curve on that one.
Oh yeah.
Yeah, we are not good at diagnosing where foreign exchange students need to go to.
We'll try harder next time.
Yeah, she's smart.
Like,
All right.
Origin.
When Zoe was here, she kept in different classes.
Yeah, Zoe eventually ends up in Cross PC.
Yeah.
Arjun-
I remember I was talking to her and she was like, I don't know
Arjun-
why I did FSC. And I was like,
Yeah, no joke. Who's the one that first showed me the calculator? Zoe, yeah. She took that integrals test and did it in about 5 minutes. So I went up to her and, I'm going to be the nice teacher. Oh, we forgot we had a test today. You didn't study. She's like, no, I got 100%. How did you know that? She's like, that's awful. It doesn't do indefinite integrals. But this one does. And then, of course, then I go back to my desk and like Google to make sure that you can't use that calculator on the test. And then I'm like, you can use that on every test. And then, of course, I emailed Mr. Kell up at LP. I'm like, he really uses this on the AP test? She's like, yeah, in the SAT. Then TI Inspired CXAS sales went through the roof for that class. So, yes. Zoe, yes. Arjun, I first met Arjun when he walked into my Algebra 1 class his first day freshman year. Later that week, he was in my honors pre-calc class.
So how did you, was he just like bored in Algebra 1?
He was bored
at-
at Cal PC, dude.
No, he especially on this one, because he likes those problems that you really got to think about. You got to like understand them.
Theoretical.
And that's the bottom line. Is if you like the problems you have to understand, that's when you think about becoming a math major. Because anybody can memorize this stuff. Like the people that use this for a living are the ones who want to understand what the math does, so they can explain it to other people. And that's how you make buckets of money. Because if there's one thing for sure, there's a lot of people out there that don't get math. They might be able to do math, but they don't get it. So, anyways, going back to that, yes. Arjun, was he bored? At the end of syllabus day, he walked up and showed me how to prove the quadratic formula by hand. Let's figure it out this fast.
Wait, from completing the square?
What's that? Yeah, well, that's how you prove the quadratic formula.
Yeah.
Just complete the square. Ax squared plus bx plus c is equal to 0. You just complete the square, and that's proof of the quadratic formula. That's how you get it.
I remember that.
If you had me for pre-calc, you remember probably having to prove that.
I remember that.
Yeah, I like that.
I remember putting that in your class.
Because I'm doing two things at school all the time. I'm growing leaders and I'm breeding future math majors. Yeah, Cameron.
You do 4.
4 on which one?
Free response.
Oh, that's a dirty dog, though. That's a dirty dog.
Before you do that,
He's been asking for a while. I got to get to Cam.
this is just
That's
a
okay.
question
Back
assigned-
to- back
I
to
feel if I leave him behind, the
Arjun,
ghost of
you
Meg
did
will haunt
this
me.
at a
You gotta do that.
The ghost of Meg is
That's
already
probably
session.
online.
Napor, I've done almost all of these problems before. That's why I had to get a new copy of this.
This is probably
Test.
online.
He asked a
No,
question.
on your videos.
Is
He
it?
asked a question.
If it's on your video.
How about let's just set it up? It is somewhere on some video. I don't know which one, though. Cameron, I will take Cameron's question. Boy, whew, and number 2, people, I don't want the ghost of Meg McCutcheon like cursing me at the end of the school if I don't ask her brother's questions.
Already going to do that.
Okay, 4C is what?
For C, find the value of the real number k, which is greater than 1, such that the integral from 0 to infinity of k to the negative x
Oh.
minus-
Is equal to 2, right?
Yep.
Oh, I love this problem. Because this, okay, back, now I'm going to seem really old again. Back in the day, they didn't let us do the U sub thing to solve integrals. You had to do this process. Okay, so if you had 3 to the x power, what's the derivative of that? 3 to the x multiplied by what? Okay, so here's what you got to do on this one. Is you got to read, they know that you didn't memorize this one. They know it. So they're saying, can you figure out how to take an integral if it's not a straight u sub? So here's what you got to realize on this one. The derivative of k to the negative x would be equal to what? K to the negative x multiplied by, kind of look at what's similar here. Like ln of k multiplied by the derivative of up here, which is -1. So this, if you had this, its integral would be this, because if you took the derivative of this, it gives you this. If you take the integral of that, it takes you back to what you had. So the first thing they realize is you did not learn this. This is one you did not learn. So they're throwing you in a new situation. Can you figure out what you need, given that you should know what the derivative is? So you should know what the derivative of a to a power is. This is just a to a negative power. So this is what you need inside the integral for the integral to be equal to this. Now, let's see if we can do that. -1 is a what? ln k is a constant. So all we need is 2 constants inside the integral. Okay, so let's talk about how we do that. 0 to infinity. Notice I'm writing k to the negative x over here. Okay, so I need a -1 in the integral. So what do I have to multiply by outside of the integral? -1. That allows me to have a -1 in here. I also need a ln k is just a what? Constant. If I want an ln k in here, what do I have to multiply by out here? Okay, this only works because both of these things are constants. If this was ln of x, can I multiply by ln of x in here and divide by ln of x out there? No, I can't take an x outside. I can't take a variable, but I can do this with constants. Okay, question. What's the integral of that? Okay, so here's where you got to finish it now. I've set this one up for you. You got to solve this. So you know the integral of this is k to the negative x. So you're going to get -1 over ln k. Oh, I forgot about the infinity. Yeah, but it's for your response, isn't it?
Yeah.
Yeah. So you got to write the limit out front because you cannot evaluate this integral properly. I just replaced infinity with b and then put the limit as b goes to infinity. Because remember, you cannot evaluate the integral at infinity. Sorry about that. I forgot about that. That's my bad. Okay, so you know this integral is k to the negative x evaluated from 0 to b. You got to take it from there. You got to take it from there. I will tell you, though, this doesn't appear every year on the free response. But you can totally meet your quota on that problem without even touching this one. So don't feel like, this one may take you a while. But this is testing if you can figure out what needs to be in there to take the integral, given that it's not a u sub problem. Because you cannot do this one by u sub because it's at a to a power. So just so you know, and I know that like me and Dr. Hatch will talk about the suffering back in the day, but this is the only way we were allowed to do integrals when I took calc. So if you wanted to take the integral of like x over x squared plus 2 dx, there was no u subbing. You had to figure out what function gave you this derivative and then what you needed inside to take its derivative up. If you go to Mines, I've heard that they don't let you do u sub. They make you do integrals this way. That's one of the reasons they make you take their classes over again, is so they can unteach any sort of shortcut that they taught you in high school. And u sub is an example of a shortcut that they taught you in high school. I did not learn this until Mrs. Massey taught me how to do it that way. And then I basically had to give up on the way I taught it because students would never listen to me again. Hi. Tell her thank you very much. She is a saint of Jesus. Saint. We are me and Mrs. Richardson are in the single parents club right now because both of our spouses are out of town the entire week. Yeah. Yep, Willow.
79.
McCutcheon, that show you what to do?
Yeah.
That is a dirty dog trick, but there's nothing you can't do in that problem. You just got to realize what it's asking. However, almost everybody leaves that blank the first time they see it because they're like, we didn't do that. And you're right. Most of the nation leaves that one blank because they're like, we didn't do that. All right, McCutcheon, which one did you say? McCutcheon, which one? Oh, sorry, Willow, which one?
79.
79. Sorry, I at least had the right region of class. 79. I feel like I've worked that one too. Oh, 79. 79 this is one this is a tough problem. this is also on the AB one, so I just worked this one last period. Francie, real quick. Yeah.
First class out
When
there.
do you want to take the quiz?
Hello.
Oh, yeah, I got this.
First class out there.
40.
Can me and Caleb take the quiz?
All right, if you're ready to take the partner pop quiz, I need you to do me a favor. I'm going to send you over to Reeboks,
Yeah, Reebok town.
who is next door today, because he's also mandatorily subbing.
Only like King Josh.
I'm not going to favorite
Mr. Partner, how did you not get money out of this deal? I mean, if I were you, I would have chosen one of my debate teammates. Like the
Oh.
Yeah, I was for her.
Yeah, I was like, I don't know what's going on.
Sorry.
Anybody else want to take this right now? Partner. Four. Head over to Rogers Simulator. Okay. It is calculator for the whole thing.
Different partner groups.
Yeah, so let's say
Yes,
part,
that's a good
my
partner.
partner sit here,
Okay.
the other group sit over there.
Oh, yeah, I just guessed.
Next one. No, this one.
See this one?
Time wide out entire section.
Guess better next time, J-Rock.
I'll guess
Why
better
did
next
you
time.
do
Yes.
this?
Because
Instead of wasting white.
Yeah,
I'm sorry, I will buy you more. I'll get magnified.
Well, remember the
Make
subtraction.
sure that she makes you pay for it.
So I already.
Will it open?
I don't have a dog either, so I have absolutely.
I will cats.
Because that's just constant. 0 times any constant is that.
So then that shows.
Yeah.
Want me to cat sit?
There is a K that exists.
No, because I don't trust you with my cats.
Yeah.
I freaking love cats. So
I also have already lined up cat sitters for every vacation we
Let's
have
change
this
it to
year.
0. So you're going to get a subtract negative.
My cat's one.
And you would also have to learn how to horse sit as well, which I'm definitely going to do.
All right, this one. All right, this one you must use your calculator for, and I'm going to talk about what you got to do on your calculator. This one I do not have an easy way to do, but it's a calculator problem, so you don't have to mechanically do this one. So this one, there's a museum, I believe. Yes, a museum. There's certain people in, certain people going out. F of t is how many, the function that tells you how many people are going into the museum. G of t is the function that tells you how many people are leaving the museum. So if you had f of t coming in, g of t coming out, how many people are in the museum at time t? F of t minus g of t. Okay, so then they ask us to maximize that equation. So we would need to take the what? The derivative, right. Conveniently, they gave us f prime of t and g prime of t. Because what's f of t minus t's derivative? What's f of t minus g of t's derivative? No. F of t minus g of t. Okay, you're answering harder questions than I'm asking. X squared plus 9x. What's the derivative of that?
2x.
Right, because you took the derivative of the first term, and then you took the derivative of the. So what's f of t minus g of t? What's the derivative of that? F prime of t minus. Okay, so by your calculator, go to the graph, type in f. So type in f prime of t minus g prime of t. So in other words, 3 times 1.02 to the t minus the quantity, 240 plus 240 sine of the quantity, pi times t minus 4 over 12. That's going to give you a graph. Throw that in real quick and see what that graph looks like. Right.
This is open note, right?
Is it a good one?
I'm gonna say no, just so you don't.
By the way, too, when you are done with your corrections and ready to turn them in, which I would love to happen on Friday, please just give them to me and I'll show you where to put them. Josh.
Do we have time for a free response? Another free response today?
Yeah,
Or do you want to do
you can
textbooks
go till
instead?
40.
Or do you want to do like turning textbooks and stuff?
Oh, crud. I forgot about that. I will do that and then I'll see how much time I got left. All right, question. The interval they gave us for this is only between what? Okay, 1 and 11. So for sure, we're going to have to check what 2 points. Because even if using the calculus, it is possible that our best value is either at the top or at the bottom. At the top or at the bottom. So they are telling us though, or it's either top or bottom. Beckman, come on. The start or the finish. The start or the finish. It could be there even if we don't want to. Okay, so let's go through the next one. And not a group project.
I mean, she can have this piece of paper. It just happens to have specific math on it.
No. Not unless she generates it. She cheat. Not unless she generates it. It's your final. You gotta do
It's
it.
actually a practice AP problem.
Okay, well,
Let's hand her the practice AP
Right.
problem.
there we go.
Here, some
Right,
practice.
so bad news is there's going to be two spots that crosses the x-axis. Which one of those two do we use? The one where it goes from increasing to decreasing or decreasing to increasing? Increasing to decreasing, right. So that limits it down to 3 points. How are we going to determine which one of those maximizes the number of students in there? How are we going to actually determine? Because this integral, look at how bad these integrals are. So you got two choices. You can use the second derivative test. So in other words, you can have your calculator find the second derivative of that and see which one of those three has a negative concavity. Why do you want a negative concavity to maximize? Right. Or option B, you could have your calculator take the integral of each one of those functions, take f of t minus g of t, and plug in 1, that critical value you got, and 11, and see which one will give you the largest value. But that one is definitely a calculator-driven problem. You cannot do that one by hand. That's a calculator-driven problem. So again, two options. You can take the second derivative, see which one gives you a negative concavity, or you can take the calculator, plug in your derivative, have the calculator take the integral of that for you, and then plug in 1, 11, and whichever point you got from the first derivative test and see which one gives you the highest value. Give me.
This doesn't want the first 4 terms.
No, a fourth degree polynomial is going to have x minus 1 to the 4th power. Okay. The first 4 terms is 4 terms. That fourth degree is actually going to be 5 terms. Yep. No. That's the third term, not a third degree.
Okay, so, that whole thing is
No, that's a third degree. T third degree of x.
okay.
I can't remember. Is that the number of terms? Who's got their book up? Can I borrow the book real quick? Oh, actually, can I borrow your free response? I need number 6 on your free response. I don't know the answer, but I know where the answer is. I don't know where the answer is. I don't know the answer, but I know where the answer is. No. Hold on. No. Yeah, that's a fourth degree. Remember if that is E. Number of terms of the x. Anybody got their book up? I can steal from them real quick. The count book, yeah. Thank you. Oh, would you like to turn that in, by the way?
Yeah, that's why it's here.
Capture.
Whoa.
Dang.
Okay.
Okay, some people, apparently, like, I give answers to people and everybody thinks that I'm like super sassy when that's just like my
You're
regular voice.
You're really not.
Well,
I'm
hang
really
on,
sorry
sorry, I
that,
can help
like-
with that too. Okay, so T7, no, approximate sign P7. So you go to the part A as a 7th degree. So that is the degree, not the degree. That is the degree.
So this would be a T sub 4.
T4 sub x.
Wait, so how does he have some? Wait, no, I know, but that would be T sub 1.
Oh, no, because that's the degree. The degree of this is 3, which is why it's TC of 3. It's got 4 terms. So this is the degree. That's why I remember that. Because some of the terms could be 0. So this is the degree of your Taylor polynomial, not the number of terms of your Taylor.
And because I don't remember what the answer for this wants, all the terms are just
The 4th degree term. So the first terms leading up to the 4th degree polynomial. All right, first term.
How can this?
There could be up to 5 terms in a 4th degree Taylor polynomial, but some of them may end up being 0. So that's why you listed by degree, not the number of terms. That's
How
why.
can this time period? Because I thought it had to be continuous time.
At 4. It has to have a derivative. In other words, the derivative from the left has to equal the derivative from the right. That one is possible because it's negative going into that point and it's negative coming out of that. Let's see what we can do. Okay. Is number 1 right? No, because the graph of the derivative function is so this is the derivative, which is the following should be the graph of f. Okay, so this is the graph of the derivative. So the function is doing what from 0 to 1? Decreasing, right? Is that eliminating 1 to 3? It also has to be 1. So is that right? Is that right? Is that is that possibly right? Is that possibly right? Okay, so now we got to say it is decreasing between 4 and 6. 4 and 6. No, 4 and 6 is increasing. 4 and 6 is increasing. 4 and 6 is increasing. 6 to 8 is decreasing. 6 to 8 is decreasing. 3 to 4 is increasing. Okay, so we have to decide if it's cusp or is it a discontinuity. Which one do you think it is? What do you think it's a cusp? Oh yeah, sorry. Give me just a minute.
You just tap one time and you're done.
What is the tangent line doing as it goes to a cusp? Yeah, it's going to a vertical. Now we're going to go to a vertical tangent line. Yes? No, so it has.
But it says that it's 2 well, I thought it was
Which of the following? Oh, it's true. Which of the following could? Wow, that's a good answer. Yeah, it could be. It could be 2 or 3. Because we don't know what the slope of that function is. So it could be a discontinuity or it could be a cusp. Wow, that's an abstract word. All right, quiz. Check in book. Quizzes are right there.
Awesome. Do I need
And
to
book.
do anything? Do we need one for each of us?
Yes.
Okay.
Because you can disagree.
Okay. Good. You have my book?
Just a second, let me make sure it's the right book. Willow Aldridge. I should be getting 93. No, 95. Yep, 95. Oh, Willow.
I know
Willow.
Beckman.
Good. That's awesome. Do you have this form?
Oh, I do.
Yeah, I need to sign it when you turn your book in.
What the heck?
Oh my god. Oh,
Stofferson. Oh, crud. I didn't check your book. Ha 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 ha. So it's the right one. 33. 33. Okay. Willow, good luck in life. Josh, good luck in life. Yep. All right. Anybody else got random stuff to turn in? Quizzes to take? Okay.
So do we got time for free response?
Yeah, what do you got?
Sick. Either of the free responses on the calculator section.
Okay, pick one.
How about 2C? If that's good.
2C?
Yeah.
Did I just do 2C?
No, you did 4C.
Oh, okay. Oh, I did 2C last. Sorry, I did 2C last period.
Do you want to do 2A?
No. I want to do 2C first. 2C is independent of the rest of the problem. Of the rest of it. 2C. 2C is easy. Oh, this one broke my heart. Okay, Josh or Alexis, can you read 2C to me?
Okay.
McCutcheon! No helping. This is not a group project.
Okay, one salesperson believes that starting with
2C. Yes.
2,400 games per week at time T equals 12.
Hold on. Okay, so did they give us a WFG? This is G of T? Okay. F of 12 is equal to 2,400. Okay, keep going.
The rate at which games will be sold will increase at a constant rate.
Stop. Take out your hands. What's a graph look like that is increasing at a constant rate? Yeah, so
Which one is this?
2C.
On free response.
2C. Okay, so as soon as you hear the word linear equation, you need to think, oh, it's T, not X. T. And I need T instead of X. T instead of X. Okay, that's the calculus version of the linear equation. What was that?
F of what?
F of T minus F of A. is equal to f prime at A times t minus A. I wrote x instead of t. I should have wrote t because this question is in terms of t's. Which is the same thing as our algebra 2 equation. Y minus y1 is equal to the slope times x minus x1. But this is the calculus version of it because it's using derivatives. It's the algebra 1 or algebra 2 version of it.
Based on this model, how many total games?
No. We need to fill in the blanks here. Okay, what's the derivative at A?
100.
Okay. What's the input value we know? What's the input value we know? We know, we're at 12. What's our output at 12?
2400.
Right, so there's our linear equation. This is our model for this one. F of t is the number of games. We need to declare that.
So were we supposed to memorize this originally? Like f of t minus f of a?
Yep.
So that's something we should argue.
Yep.
Okay.
It's the calculus version of a linear equation. Because that's what allows us to talk calculus on this. This makes it a calculus answer, not an algebra 2 answer. All right, so solve for f of t. What do I do to both sides? Add 2400. So 100 times the quantity t minus 12 minus plus 2400. I should have said add, not subtract. All right, ladies and gents. Now, Alexis, what do I have to do with the rest of the equation?
Take the integral.
Right, the integral from where to where?
12 to 20.
Of this. Can our calculator do this for us?
Yeah.
What do I got to not forget at the end?
dt.
Also, you have to put
And
games.
this is on the
Now, your answer, yes, because this gave you the rates of games sold. What will your answer be when you take the integral?
Games.
Just games, right? Other way, Ayana. When you take the integral, you go backwards. When you take the derivative, you go forwards. So if you're given a rate and you take the integral, it just takes you to things. Like if your rate is things per hour, you take the integral, it takes you back to things. If you take it within, yeah, good job, Haley. Look at that. She's getting answers for free today. She's not even in this class.
would you have to put 0.000?
I think that one asks you to round it to the nearest game. So that one you don't round to the thousandths because they gave you more specific directions. So I think that one you round to the games, then part D you don't.
If we do get, if there is one that doesn't say round to the whole number, but we do get a whole number, do we still put 0.000?
No. And QE asked that earlier, like if you got 12.5, you just put 12.5.
Okay.
If it's 12.501829, you go to 3 decimal places.
Okay.
Yep.
Why
Yeah,
did I get a point?
because that's wrong.
But then why did I get a point?
Set up.
Hold on a second.
Really?
Really?
Oh my gosh.
Ayana, if you ask,
That is complete.
if Dr. Ayana Lang
Butthole.
is in charge of removing my kidney,
0.1?
yeah,
That is the butthole.
yeah, part A, Josh, oh, part A, yeah. Part A, I gotta get a copy of it though. Let me grab one real quick.
I honestly have no idea.
Butthole.
Oh, I can totally sell a 10th of a
Nearest
game.
whole number, my bad.
Yeah, but now I'm gonna ask you around nearest soul number. Josh, let me get a
You can
copy
sell
of that.
5 playing cards out of a deck of cards.
All right.
So you can do it again?
Right, here we go on this one. A store tracks total number of sales. Approximate. Number 2, part A.
Can we do just all of them?
I'll explain what you have to do for it, yes. Approximate the value of G prime. Now this one, they gave you games per week. You got to find the derivative of that. How can you use the data up there to approximate G prime at 8? Well, 8 is halfway between what?
10 and 6.
10 and 6. So take the slope between here. Make sure you denote it that G prime of 8 is approximately the slope between these two numbers. And make sure you get the units right. The units are in what?
Games
Games per week.
Squared.
Squared, right. Games per week
This
per
is
week.
the only thing I learned in Top AD. We did so much. I remember this.
Good. Okay, and then part D. Estimate the Riemann sum using the right Riemann sum. Okay, the problem is you're going to use the right value. So you're going to use this one, this one, this one, and this one. How far is it from 0 to 3?
3.
How far is it from 3 to 6?
3.
Dirty dog trick then. What's the distance between 6 and 10? So you got to remember to multiply that one by 4. And then what's the distance between 10 and 12? 2. You got to remember to multiply that one by 2. So use this value, multiply by 3 times 4 times 2. Sum all that up, you get your right Riemann-Sum approximation. Remember, use correct notation. It asks you what's the meaning of that. If you have games per week and you take its integral, that is the total number of
Games.
sold between 0 and 12 weeks.
Do I have to put games per week, or can I put G over W?
You cannot put games per week for part B because you took
for part A.
for part A. You can put games per week squared. Yes, G per W or
Can I
G
put,
per
like,
W
G over
squared.
W squared?
Yes, but
Second.
yeah. What's up?
Can you finish it at a later time? or
Yeah,
just
you can finish it right now, Mish.
No, I have
Okay.
good lunch.
Can I just stay
Put it in the
here
printer
for a
then.
minute?
Yeah, you can, but I'm going to.
In the printer?
Yes, in the printer. That's where all unfinished tests. Don't forget, if you're watching this on the web, there is homework due. Homework due. Make sure you get a copy of it from me.
Right,
Wait,
what class are you studying in?
Rogers, just right next door.
Okay, can I